Alright, making a video. I think so. Draft physics and such. Looks like it's recording. Alright, this is, I've just been, everything been going wrong lately. So my little smoker died. This alien schmuck thing. It's pretty schmucky. Yeah, I thought it was kind of crappy built from the beginning, just because the battery compartment is this stupid sliding door thing. There's not proper springs, never closed right, and so it did pop. Had a piece of plastic between the two layers, so the one layer holds the battery down, the other layer holds this thing up to contact the tank, and it just broke through. That's one problem it has. And then I think there's a little switch over here. You have to click this switch 5 times to get the thing to work, and I think the little switch is fucked. But anyway, just got a couple of problems, I think. It appears to. I mean, it works in the sense you put the batteries in, it does the initialization, but it doesn't load the full software. So anyway, just showing this camera is really good. You can see stuff really good. So it's just one of those $5 Chinese scope cams, and but it's really good for fixing little tiny things. This is little tiny stuff. But anyway, but you have to hold it still, which I'm not doing. So anyway, just since it was something I was working on, but yeah, it just is irritating. Good news is my old smoking device still works, so I have some decent batteries now, so I'm not doomed. Yeah, it's not bad. These don't last too long. They're like 6 years old or whatever. But anyway, just nothing been going right. So that's just a big waste of time, and I had to look for all my old stuff, and I couldn't find half of it. And I have one of these blue things, but the problem with that one is that it's very sleek, very nice, but as I predicted, the battery's just starting to die. It's just not enough battery for, and there's no way to replace it. And, so it still works, but it's not very full functional and all that stuff. So there's a couple of subjects I wanted to get to, so maybe I'll do some which one first? Well, I just point out Hoffler, they made some video on higher dimensions, just useless mush. I mean, you should just point out how, well, really in 99% of physics there's absolutely no need for extra dimensions. These extra dimensions are only needed really to fix mathematics that just doesn't seem to work quite right. And so assumptions they have about how things are working, and their model has some holes in it, and they fix the holes by inventing extra dimensions. And that's all this extra dimension talk is just such a waste of fucking time. And I don't know why he finds any of that at all interesting as a subject, because it he should realize that there's a low probability that extra dimensions are at all necessary. Even the idea of time as a dimension is foolish and stupid. Time is a thing that passes, frankly. It's a function. And, you're not going to bend it or break it or play with it in any way whatsoever. If intelligence could have done it, and we assume that intelligence is something that happens in the universe, then it would have already figured it out, and they'd be here saying hi. So anyway, it's just such a stupid waste of brain space to have these silly conversations about anuses on gremlins. I mean, this isn't even a conversation about a gremlin. This is about an anus on a gremlin. It's so uselessly disconnected from reality. So it's just so depressing. People can't stay on a subject. I have to find somebody who wishes to be convinced. I mean, just tell me you're unconvinced, and then I'll go step by step, and you explain to me where something doesn't make sense to you, and I can figure out if maybe I can fix that. And that's what I've attempted to do by you know, going over this list of stuff. Jump ahead here. You know, so I'll post this list below, just with keywords pointed out, what the basic functions are. So I did add these. I might as well read them. So we stopped at acceleration. So voltage is a measure of the amount of momentum being transferred per atomic exchange, which that basically means is voltage, the way electricity moves through even weak mediums like atmosphere, is by transferring pressure from one atom to another, and pressure in the form of the pressure between the electrons, I would argue, quite simply, quite obviously almost. And the idea is how firmly you push your neighbor, and that's basically voltage. So if you hit them hard with a lot of momentum, so the electron has a lot of momentum, it pushes essentially its momentum against another electron because they're repulsive, so their fields interact and they push against each other. One field hits one electron, the other field hits the other electron, that way, not field on field. But anyway, and they essentially pass on their pressure that way. And so the more energetic the electron is, the higher the voltage, and the more momentum transferred per interaction per atom, and that would be voltage. And then current just means, I'll read it, is a reflection of how many atoms are involved in the process of exchanging momentum. So current is just saying, instead of transferring a lot of energy through just a few atomic interactions, you spread it out over a lot of atoms and just do a little bit of hitting on a lot of atoms. And the key to current is that current is what you need to make the atoms magnetic, that is, polarize them. And you just have to polarize them. You don't need to polarize them with a high voltage. The amount of pressure doesn't help you any. The real key is to have as many atoms as possible pressurized. That is, once they're pressurized, just as I've explained before, my hand is more obscured the closer this is to you, and that's polarization. So the further out the electrons are from the proton, the more the atom looks negative or electron heavy, and the less proton you're seeing. So that's what's happening when their electrons exchange pressure. They're exchanging dimension, and they spread out a little bit, which means they become kind of dominant, and the proton becomes recessive. And that's the polarization that, when you add all that up, becomes a magnet. So to magnetize the material, you have to activate all the atoms. You need as many atoms as possible polarized to create a good magnet. So current is necessary to create a magnetic field in wires. All right. Time is a byproduct of the fact that momentum does not move distance instantaneously. Now the catch is a transformer is a little different, just because you're using a ferrous material to accelerate the creation. You don't have to create the dipoles. You don't have to create the polarized atoms. The atoms are already polarized, so you don't need the current with ferrous material. So then voltage can work. Anyway, time is a byproduct of the fact that momentum, the little bits, the corpuscles, the ether, whatever you want to call momentum, little clumps of momentum, that's essentially quantum mechanics, is little clumps of momentum. That's really all it is. A clump of momentum, whether you want to think of it as a wave, it's okay. I'd say it's wrong, but if you want to think of it that way, I'm not saying you can't. Alright, maybe we can have agreement. I just won't say ether, and you don't have to say particle. We'll just call it momentum, clump of momentum. does not move distance instantaneously. But the irony is that all these ether people want to break the speed of light. Because apparently, like I said, they're just unsatisfied with a universe that has a speed limit. So they're pretty much just wishing that it wasn't true. They don't have any evidence that it's not true, but it is just a fact. So momentum takes time to get from point A to point B, and that's why time exists. If momentum could move instantaneously, then there wouldn't be any time, and there wouldn't be any universe to talk about. Alright. Magnets don't make force, they just filter the momentum force of gravity, which is not really gravity, it's just the force, okay, the one force, the little mixed bits of electron energy and proton energy, momentum, electron energy and proton momentum coming in all the time, and the magnet segregates it. Electron energy out this end, proton energy out that end, that's it. That's all the magnet does. Doesn't make energy, doesn't do anything but filter the energy that already exists. Electrons and protons are the charge monopoles of dipole magnetism. So the electrons and the protons are the magnetic monopoles. They're the charge monopoles. They're the monopoles. The electrons are negative, the protons are positive. They reflect the forces reciprocally. Electrons reflecting electron force, and protons reflecting proton force. That's simple. That creates your magnet. It's all tied up. Charge and magnetism, same phenomenon. The only difference is charge is separating, right, electron from proton, and when they're stuck together, dipoling, then they're a magnet. And if you take two giant monopoles, like a big negatively charged ball and a big positively charged ball, you can never get them close enough to create a dipole. So you can't make a magnet out of them, because they will lose their charge through the atmosphere long before you get them next to each other. Alright, charged objects have a momentum pressurized or depressurized. Charged objects have momentum pressurized or depressurized. Well, I didn't write that right. Charged objects have momentum pressurized or depressurized atoms. So I'm saying okay, charged objects have momentum pressurized or momentum depressurized atoms, meaning there's either more pressure in the atom, the electrons are expanded, or the electrons are contracted, which means now you're proton heavy. So if the electron is contracted, weak in its pressure, then the proton is strong. Electron is out, electron is strong. Alright, electricity is, well, I better finish this. Not necessarily more or less electrons. So you can add an extra electron to an atom, create an ion, or remove an electron, and that's going to make for more or less pressure, right? You can understand if there's 5 electrons and I take one away, the 4 will end up going smaller. That's understandable, right? And if I have 4 and I add another one, well, the 5 is going to need a little more room. So you can sort of understand that adding an electron will polarize an atom, but you can also just polarize it by adding force. More force between the electrons, more polarization. Electricity is the transfer of momentum pressure from atom to atom. So that's all it is. It's just the force moving like a laser beam through the atoms, just transferring between the electrons. The electrons push into each other, the next electron pushes, the next electron pushes, they just push. And as long as something keeps pulling the pressure out, they'll just keep doing that. And if it's alternating current, oh, it's really easy. So the electrons don't have to go anywhere. They can just stay right where they are and just go back and forth, back and forth, back and forth. Really easy. And the electron can go out, in, out, in. The atom just expand, contract, expand, contract. That's all it does. no neutral position. It just keeps going from too small to too big, too small to too big. Alright, so, yeah, it's just all there. But I mean, it would just be nice if I can find somebody who is, who doesn't believe any of this crap, and just explain what sentence here you have a problem with, and I will attempt to fix your problem, if you can explain it, why you have a problem with it. Because these are, in my opinion, pretty good definitions. Very good definitions. Very close to what the truth is going to sound like when we finally have it. Alright, so guess I'll go do a comment, and then I'll do some commentary maybe on the time thing. You know, just a couple of the twin paradox crap and the, you know, the light clock and stuff like that maybe. So just no comments, which is just, you know, I don't know what I can do here. I mean, I'm making an honest effort, and you know, there's just nothing. You know, there's just, apparently I don't have any viewers who are anything other than wacky, you know, some other kind of nutty theory, but no civil defenders of regular physics, apparently. Yeah, the battery didn't connect right. I'll have to, a few bugs to work out. Okay. That should do me for a while. Anyway, alright, so this is a link to one of the Ken Wheeler videos. Okay, so it says, I stopped when you had no clue that EM waves like light have a transverse component. So, you know, these assertions about, you know, somehow you know this to be a fact. There's no real facts. It's just they made up the model. They didn't videotape photons somewhere, okay? Somebody made it up. I don't even think Maxwell did, but somebody just made up this idiotic sine wave crap, which there's just no evidence that photons do sine waves. There's no evidence that there's two components. There's just no evidence of it. Alright, there's certain behavior, and you can explain it, you know, mathematically by splitting up in a lot of different ways. But it always comes down to the fact that there's no evidence of this. So you can keep claiming it, but it just, and the paradoxes it creates are just so obvious. You know, because they think this has something to do with polarization. And you say, well, you know, if you're stripping half the photon's character, that is, all of a sudden you've broken the magnetic wave by polarizing the light. Well, how did the photon function if it doesn't have both of its waves anymore? I mean, all that doesn't make any sense at all. Anyway, transverse plane wave in linear polarization. See, he's doing this with this polarization crap, i.e. oscillating only in the y direction as opposed to, so again, how do you strip half the character of something and then just what, magically put it back again? I mean, it just doesn't make any sense. A light wave is an example of a transverse electromagnetic wave. Says you. You're saying wave is an example of wave. You can't even see how circular this is as a statement. Doesn't mean anything. It's all just made up. Again, show me the experiment that demonstrates that a photon is anything like a wave. And I'll just play the Feynman clips over and over again. Okay, you think Feynman doesn't know? He doesn't know the magical experiment that proves it's a wave, and so he doesn't know not to say it wasn't a wave? The shape of the wave is one of the sinusoidal plane wave solutions of the electromagnetic wave equation. So again, there is no electromagnetic wave equation in the first place. There's just an angle equation. So again, I don't know, show me the wave in the wave equation. Show me where there's a wave in it. Anyway, there's just no hope for these people. I mean, they just bought into a pile of crap, and they think there's some big pile of evidence, and there's just really no evidence that's any kind of evidence. Alright. So, kind of a rubbish comment, so I'm going to delete it because it's just rubbish. Yeah. Alright, so that's it. Just no comments. Nothing I can do with nothing. And the more, like I said, the irony is I'm spelling it out and I'm getting no reward for doing that. You know, so I make it as just putting it in writing, and I still don't get anything to work with. All right, so yeah, so let's do which one? I guess we'll do the time dilation thing. So, and let's see if I go anywhere else. I don't need all of that. This is fine. So, I wish I could get this a little brighter contrast. I can't adjust the video settings, which is a little irritating. So I have to figure out some gimmick to get around it. I probably have to just add more light, right? Boy, that's nice. But, oh, okay, yeah. Yeah, that's pretty good, actually. So maybe I'll just try to make a stand for the flashlight. Yeah. It's sort of a pain in the ass, though. Yeah. See, my hand will get in the way anyway. Well, if I put it from behind, that'll probably work. Then I have to figure out how to connect it, tape it, and all that crap. I don't want to do that. I'll have to think of something else. Yes, that's what I'll do. I'll think of something else. Alright. Alright, so the real paradox of this whole time dilation thing is that the twin argument is kind of silly, just because you're saying, you know, based on their own theory of the fact that you can't tell who's moving and who's not. So the spaceship leaves with a, you know, the other twin on it, and and so it's going velocity plus, and this one's supposed to be going velocity. That's the assumption, right? But there's no reason. Whoa, okay, sorry, my mistake. I did fix at least it's going the right angle now. All right, so so the assumption is the thing going faster is going to be time dilated. And then you can even argue that if it turns around by going into gravity, so let's say, you know, because sometimes people think that you have to slow down and then reverse to get back home, when you really don't. You just have to find something gravitational to loop yourself around, and you'll end up with the same. You'll end up changing your direction without having to stop. So you'll even go faster as you're looping around. But then you'd be in more gravity, so then you'd have the other relativity theory would kick in, because then you go into a gravitational field, okay? And if it's a black hole or something that you loop around, then you can pretend that gravity also accelerated, you know, your time dilation. So you could get even more time dilation by looping around gravity. But anyway, the point would be, though, is that you don't really know what this velocity is you started with. So if this velocity, you know, if this planet was moving in a solar system, it just happened to be going this way in the solar system, and the solar system just happened to be going this way in the galaxy, oh damn it, you could have had a substantial velocity going this way. And so when this guy takes off and goes this way, he's essentially reducing his velocity, because this guy's still going this way and this guy's just not. And that's really the only difference. This guy thinks he's going somewhere, but he's really stopped going this way, and he's the one that's lost velocity in a real sense. And you really can't tell. There's no way to know one way or the other unless you shot the guy, you know, shot a twin, like say it had 6 tuplets or something, you shot one in each direction, and then you might be able to figure out, based on how much they aged difference, which direction this guy was going from the very beginning, because some are going to add and some are going to subtract. So the point would be is that this guy could age a lot more, because he's the one really going somewhere, where this guy's now stationary-er. He's more stationary, based on a lot of collected momentums. So clearly it just doesn't work as a logical statement. you know, in the sense that I think this, if you could really do this experiment, it would prove that we do have absolute velocity, that the initial state was a certain velocity and time was a certain dilation already on this planet, and then all you're doing is doing something relative to that, which is either going faster, you know, if you go this way, you know, you're creating even more velocity, or if you go the other way from the motion, then you're creating less than the thing you started with, and that's the way it would be. You know, the vector, whatever vector is the combined velocity. We all have a combined velocity theoretically. I mean, just logically, you can sort of get the idea that, yeah, I'm going a little this way, you know, the Earth is turning, I'm going that way, then the Earth is moving around the sun, and I'm going that way, and the sun is moving in the galaxy, and I'm going that way, and then the galaxy is moving in the universe, and I'm going a little bit that way, and all that's going to add up to something, and that's your real velocity, and that changes all the time, but you don't notice it because you're accelerating all the time anyway. You're in a constant state of acceleration because you're in gravity right now, and you are falling, whether you perceive it or not. It's happening, and then you're being pushed back up, and then you're falling and you're pushed back up. That's just a fact. What's another fact that, I mean, maybe I should write it down as a fact and see how many people want to argue that that isn't true. Because logically it's the only way it can work. Alright, so is there anything else I got to say about this? So just again, just the assumptions built into it. Again, if we could do these experiments, I think they would prove the point that all of this time dilation stuff, it is just about velocity in the end. The gravitational component just has to do with the fact that gravity accelerates things. And that's all there is to it. And if you don't allow the thing to be accelerated, which I'm sort of saying is not possible, because it's still going to, whatever you stop it with, okay, whatever you try to stop something with is still also in the gravity, and the pressure is realized. And the only thing that holds it up is the fact that pressure is being applied in the opposite direction. So it's still pressure against pressure, and you're in between, and the two pressures are going to still move you like this. You're going to jiggle in it, period. No way around it, because the pressure is in the form of these little bits, and the little bits can't be at a perfect, you know, you're never going to get hit by bits at exactly the same moment. At any one moment there's going to be a little bit of quanta of momentum up, and it's not going to be hit right away with a quanta going down at exactly the same position inside the material. So constantly bits will be moving up and then stopping and reversing and then turning around and reversing, just like the energy, the momentum between the electrons. So there's no way, the Planck constant of momentum is so tiny, there's no way that you could get hit exactly the same from both sides at exactly the same moment. It just won't happen. So you'll end up moving, and you'll end up having velocity up and down as well as your velocity forward, and as I explained, that does make longer lines, and that sort of gets to the light clock crap, garbage, trash, nonsense. Alright, so you have this idea of a way you shoot a photon through a mirror, let's say you could do that, like the you know, yeah, let's just even say you could just have it a little tiny angle off, so the light just kept going back and forth, but so close you almost couldn't perceive it. Yeah, I really want to try to do that, actually, as an experiment, just to see how many times I can get the beam to go back and forth, you know, and blow smoke on it and see if you can see how many beams go back and forth before it degrades beyond usefulness. But anyway, so the idea of the light clock would be is you get this beam going back and forth, and if you have movement in a direction, okay, their theory is that somehow this photon that travels in a straight line, you know, isn't going to do that. That it will go into the future with the motion and, you know, bounce off the mirror in its new position. So as the mirror moves, the photon somehow knows to go at this new angle, which I'm arguing is just nonsense. And obviously you could sort of prevent that by just having the gun for the photon, a tube, you know, that would just make it impossible for the photon to come out at an angle. And so it would have to come out straight, because if it came out at an angle, it hit the tube and just wouldn't make it out, something like that. But clearly what I'm arguing is that if you could possibly do this experiment, it would be just like the twin experiment. It would tell you how fast you're going, because the photon would come out straight, and it would come out at its constant speed, constant coverage of distance. And as it did that, when these mirrors move, okay, the photons are going to appear to have lagged behind, because they're not going to move with the mirror. So once the photon comes out, the mirror moves forward, you know, the photon's going to keep going straight. And straight's going to mean the back of the ship is where it's going to hit. So you can sort of get the idea of if the fin of the tail was here and the point of the ship was here, you get the idea that if you shoot the photon here and the ship is moving, you know, as the photon's traveling, the ship is going to move forward, and so the tail of the ship is going to end up here by the time the photon gets across the ship, and the mirror is going to be up here somewhere. And, you know, the photon's not going to go forward to hit the mirror. And if it did, again, this distance is the wrong distance now. And you've broken, okay, reality, physics. If you want physics to be the same in any frame, you have to recognize that photons aren't going to change their direction. They're not baseballs. They don't carry two momentums. It's not like throwing photons isn't like throwing a tennis ball back and forth on a moving bus, because photons don't have two momentums, and tennis balls do. They do the conversion. They figure out, I have a component in this direction and I have a component in this direction, and they add the two components up and they go sideways. So they literally jump to the forward position. So when I throw it at you, say the bus is going 50 miles an hour this way, and I throw something right at you, what happens is when I throw it, I don't throw it at you. I actually throw it over there. That's what's happening, because the two velocities are being combined, and as soon as I let go of the ball, the two velocities are combined, and that's where the ball heads, because it's going 50 miles an hour this way. My hand is going 50 miles an hour that way. I don't see it doing that, but that's what it's doing. And so when it releases the ball's saying, I'm going 50 miles this way, and I'm going 50 miles this way, and it gives you the vector in between. And it's not always in between. It's not directly in between. But anyway, and that's how it's going to work. Photons aren't tennis balls. They aren't basketballs. They aren't material things. They can't have two momentums. They can't combine two momentums. They just go from point A to point B in a straight line. And once you launch one, that's it. That's the direction it's traveling. It's going to keep traveling that direction. It's not going to say, oh, wait a minute, I have to account for the fact I'm on a bus. It doesn't care that it's on a bus. And Einstein sort of said that, but again, all this confusion, it's hard to tell sometimes what Einstein actually said would happen versus what other people are saying Einstein would think. So I don't know if Einstein was that dumb, you know, to think that tennis balls do have two velocities. Photons, but they don't. And it's just garbage. And again, it would show you, quite obviously, Einstein just made up a silly rule, okay, that you can never tell who's got what velocity. And the simple argument is, yeah, you can tell. And if you actually did the experiment, the light clock would act just like a speedometer. It would tell you exactly how fast you're going, because the faster you're going, the more the beam would appear to be landing in the back of the ship. Okay, even though it's not really doing that. It went a dead straight line, and the back of the ship came up forward to hit it. So you moved, the ship moved, the photon didn't. So it's going to look like it went backwards, but it didn't. It went dead straight. Alright. Yeah, so I don't think there's anything else. I mean, this stuff is just so full of holes, and is so crappy as an explanation of reality, and it's just amazing that You all fall for it. You all say, okay, give me more garbage as a belief system. So I was thinking I might make a yeah, I probably shouldn't announce that I'm going to make such a video, but I mean, yeah, you could almost make a video just you know, a bit of humor, just mocking this because it's so bad, and I guess maybe that's why you're all so desperate to pretend it's not wrong, is because if it's found to be wrong, yeah, in hindsight it's going to be, well, you couldn't tell that it was wrong. Wasn't it kind of screaming this is the wrong answer, like dark matter? It doesn't just scream contrivance made up to fix a problem that shouldn't exist in the first place. Their stupid math, because they made wrong assumptions about how galaxies work. We have to invent an entire new form of matter. I just don't see how that just sounds a little bit too crazy. You know, annihilation, they call things annihilation events when nothing's really annihilated. It's just borrowed from the future. Borrow from the past, give back to the future, that kind of, you know, just silly notions. Stuff that can't possibly be the right answer. So I guess what, you know, that's it really is the emperor's wear no clothes kind of thing, and you're all just embarrassed to admit that you're all playing along with a dumbass pile of crap, and you all got duped. You were stupid enough to pretend. I don't know. You know, just there's so many things. It's like I saw even just the title on a video the other day. It was like a TED Talks or something. It was about voodoo. I'm trying to think of it. It's the same as voodoo. What do they call that? You know, when you power of suggestion, hypnosis, and you're just like, oh come on, you just horse shit, right? I mean, it's always a gimmick. It's like a seance or something, or it's like a Ouija board. Come on, it's just bullshit. No real rational person, okay, starts whatever clucking like a chicken because some person with a little bit of fancy vocabulary, they say some words to the person and all of a sudden they're a chicken. I mean, get frickin' real. You know, come on. Oh, they hit my I have no control over my brain button and I now am going to just do something silly. Oh, bullshit. They're just playing along. Come on. Get real. It's like somebody channeling their past lives or something. I mean, you can't see that this is obvious bullshit? That human beings have been, throughout human history, compulsively full of shit. They're lying scum. They just can't stand, you know, telling the truth. You know, every story turns into the big fish story. I mean, they always aggrandize, they always conspiracy theory. They're always like, let's not come up with a rational explanation like lightning is an electrical discharge through atoms in the atmosphere, and the more moisture there is, the more likely you're blah 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 blah. No, let's not do anything rational. Let's pretend a God did it. You know, an angry God, because he's loud. He's yelling at us. You bad human. Come on. So, I mean, this is just so depressing. You're just like, oh, I'm appealing for people not to invent Thor all over again. And that's all you're doing. You're just doing it all over again. You're just falling into the same bullshit trap. They tell you that Jehovah walked on water. He rose the dead. We did this entanglement experiment. We proved he walked on the water. Yes, you won't be able to see it in the video because, you know, we don't have video of it. We just have a story about an experiment that maybe possibly is so complicated that nobody could follow along anyway. I mean, come on. Alright, so yeah, maybe I'll leave it there. I just don't know. I just, you know, I do want to make some ABC videos, you know, just go through it again, because apparently I have to start even simpler. I don't know, I have to make it so simple. But I guess that's the audience problem. See, I need a more literate audience of you know, defenders of this crap. so they can actually try to reference some substantial piece of evidence, and not silly entanglement experiments and silly voodoo experiments, but something really rock solid to defend this crap with. So yeah, I haven't got into the... See, all of this, you can do all of this, and I don't even have to get to any kind of notion that, oh yes, and by the way, photons are not moved by gravity, because it's so irrelevant. But clearly, the world has made this kind of crap relevant that shouldn't be. But yes, another place where the evidence is so insufficient. Sorry, yeah, the other computer's doing something strange. I'm trying to fix the old hard drive, and it's making all kinds of weird noises. No. Maybe I'll just go look real quick. I can't see what you're doing because I'm over here seeing what this is doing. No, it says it's just still looking, I guess. So I guess it's looking in a weirder way. Alright. It's just kind of noisy. But what's the difference? The hard drive's useless until I get the data off it, if I can. Anyway, so yeah, maybe I'll just make Linux videos for a while until I get some kind of interaction here. I need somebody to just, you need to have some sort of, I mean, you can't argue with just a million people at once because each person finds a different sentence broken. You have to kind of go through this step by step. I thought Hoffaday was going to stay on the subject. It seemed like he was getting there. Like he said, okay, I'll get the momentum part. And it gets this and that. And I just thought he'd stay on the subject. And instead he just started going off on all these stupid abstractions again. Somehow, no, we're not going to do mechanical physics. We're going to do vector fields. And then we're going to talk about, extra dimensions, and it's just hopeless. You don't need any of that crap. None of it. You don't need any of it. Alright, so I guess I'll call it a video. And so, till the next time and such, and so forth and whatnot. Yeah, I want to work on animations too. Now that I got it so tight now that it's. But it's, that could just take an awful lot of time. I don't know why it's doing that. I mean, it's making a noise like it wants me to do something, but there's nothing I can do. I could go over there, and there's nothing on their computer. Oh, it closed, it crashed or something. Now it's gone. Great. So I went to all that trouble, and to what? To crash? Huh. Thanks. G-parted. It's a great program. There, it's making a noise again. Now it's closing. Oh, okay. It's opening and closing partitions. It's mounting and unmounting partitions. Okay. But the program's not visible. Well, a lot of Linux programs do that. I mean, they're not very tight, and they're not very clean in terms of how they're like they'll have a bar that shows you how it's going, and it doesn't have anything to do with how much progress it's making. It's a lot of things that just don't work. But it beats using Microsoft products or Google products. So, all right, so we'll call this a video. And so till the next time. Alright, I should be in the right computer now. And